now here we just find the derivatives of the following logarithmic functions. We have dy dx, the derivative of ln x to be equal to 1 over x. Now I'm going to prove to you that this is it, alright? Now here we just have, let's make our y to become ln of x. If we make y to be ln of x like that, then we want to find the derivative of y respect to x. So if we just say, okay, let's find the derivative of y respect to x, we have the derivative of ln x is just 1 over x, and we are done. But let me show you the steps, alright? First, you know that this is ln of x. It is the same thing as saying the logarithm of x to base e, like this, right? Very nice. So if we make e the base of both sides, on the right hand side we're going to have x. Like if we make e the base of both sides, that will be e to the power y is equal to e to the power of log of x to base e. Now from log property, we know that e to the power of log of x to base e is the same thing as saying what? Well, that is just equal to x. The number right here, this and this, we take this, alright? So we're going to have e to the power y is equal to x, like this. Okay, so from here we can go ahead and do some differentiation of this implicit function. Implicit because y is a function of x, but we're having y in a function, and we can't separate y like that. So we just take the implicit function, the derivative of this implicit function, we're going to have, well, on the left hand side, we're going to have the derivative of e to the power of y with respect to y is going to become just e to the power of y. In our previous video, we were doing derivative of exponential functions. We showed you that the derivative of e to the power of x with respect to x is just e to the power of x. So in this case, this will just be like this, alright? I will multiply it by the derivative of y with respect to x, like just dy dx, and is equal to, well, here I will just differentiate the right hand side. The derivative of x with respect to x is just giving us 1. Okay, this is actually from implicit functions. So whenever we differentiate some stuff like this, we just have to remember to add dy dx. And here we are gonna make the y dx subject of formula. After all, that is what we are being asked to find. So that is the y dx is gonna become, well, if we multiply e to the negative y on both sides, right here we're gonna have 1, and here we just have e to the negative y power, like that, right? Here, well, what is y? Y is equals to log of x to base e. So we just put y in here. We're going to have the derivative of y respect to x is equals to e to the negative, y is log of e, log of x to base e, log of x to base e. Again, this is just negative here, alright? Again, from log property, we can take this negative right here to the power of x. So we're going to have e to the log of x to the negative first power. This is just negative 1 multiple. And this is base e, this is just dy, and right here we have dx. Well, here, again, we have e to the power of log of e, log of base e. So we can take x to the negative 1 power. So that means that dy dx is becoming x to the negative 1 power, and this in fraction can be written as 1 over x, and this is the answer, like that. Okay. Oh, I clicked the second one. Well, let's just go ahead and solve the second question. This was actually the third one, right? I skipped one. We had the second question to be the derivative with respect to x of ln of, here we just have 2x to the third degree, and this is it. Well, if we after differentiating this function, we are going to have, the answer is just going to give us 3 over x, like that. And let's show that that is true. Okay, so here, if we make y to become ln of 2x to the third degree, like this, well, ln here is something I said log to base e. Alright? Okay, so to solve this, I'm gonna let you know that this is a function of a function, this ln of a function, and in here we're just having another function, so we can apply the function that is the quotient. No, we can apply the chain rule, alright? We can apply the chain rule right here by saying let u become 2x to the third degree. By doing that, we can differentiate this u. We find the derivative of u with respect to x to become this, just like that. We have 6, and we keep the x, and we take 1 from the power, that becomes 2. Again, this y can be rewritten as, in terms of u, ln of u, alright? Like this, and dy, du is going to become, when we are solving for ln x, the derivative of ln x with respect to x was giving us 1 over x, like this. So the derivative of ln u with respect to u will be giving us 1 over u. And we are okay. Here, for chain rule, we're going to find the derivative of y with respect to x, and it is given to be the derivative of y with respect to the variable of substitution, that is du, times that derivative of u with respect to x, like this one. So we can go ahead and find the y dx by just multiplying the two derivatives. So the derivative of y with respect to u was giving us 1 over u, and where u is equals to what? 2x to the third degree. So we can just, in place of u, put 2x to the third degree, and we multiply with, the derivative of u with respect to x is giving us 6x squared. Just have the 6x squared. Well, here we can cancel out some things. 6 divided by 2 will give us 3, and we have it to be 3. And x squared divided by x cubed, this is to the second power, this to the third degree. So the numerator we're going to have 1, and the denominator we're going to have x to the first power. So that means 3 divided by x to the first power. And this right here is what we had. So we are done with that. Over to the next one. Well, here we just have the derivative of ln of 1 over square root of x. How? Wow, with respect to x. And after differentiating, we're going to have this as the answer, 1 over 2x, the negative of that. Okay, how do we get on with it? Well, this is actually in the same form of this one, right? Where we just have to make use of function of function. For if you have that y is equals to, this is a function of function, make use of the chain rule. So we're going to apply the same thing right here. Y is equal to ln of, this is 1 over square root of x. Well, this is just x. For function of function, let's make some substitution. Or better still, looking at this right here, now the idea is this. When you have ln of anything, any function of the independent variable, say x in this case, when you have ln of that, the derivative of ln of any function is 1 over that function. Okay, let's just do that. So we have the derivative of y with respect to x is going to give us, like I said, the derivative of x with respect to x was giving us 1 over that x, like this, 1 over this x. That means 1 on top and x at the bottom. So you're going to have 1 on top and the whole of that at the bottom, 1 over square root of x, like that. Now, again, we can multiply this by, we go inside, forget about the name x, we are done with it, alright? We go inside 1 over square root of x. We differentiate what's inside. So we find the derivative with respect to x of 1 over square root of x. This is it. And when you are done differentiating this one, you are done. Alright? This is the longer method, and this is just a simplified form of the longer method. Okay, so here we just have 1 divided by this, so we just take a multiplicative inverse. We have square root of x, as in this comes down, and this one right here goes up. Okay, and we multiply with, well, the derivative with respect to x of square root of x. This can be written as the derivative with respect to x of, this is square root of x. Okay, that is x is the 1 over 2 power, and because it's at the denominator, we just bring in a negative like this. Okay, so from there, I'll cover this bracket. We can go ahead with differentiation from the power rule. We say the power rule to be, when you have n to any power n, it is the same thing as saying, well, you bring the power down as a product or as a coefficient, we have negative 1 over 2, you multiply with the x, and at the top you subtract 1 from the power, so you subtract 1 from the power, you bring the power down like this, you multiply with x, and you subtract 1 from the power, so right here you're just going to have negative 1 over 2 times x to the power of, well, negative half minus 1. You can go and add this up, right? But the answer right there is just negative 3 over 2. Just do some simplifications, you're going to get that. Here. Now, we can rewrite this as negative 2 is in the bottom. Since x has a negative exponent, x also is in the bottom. And the exponent joins it, that is 3 over 2. And at the top, we just have it to be 1. At the top, this is just the same thing as this. So, with this, we can rewrite this again as 1 divided by 2 times square root of x cubed. Still negative of that, right? Where the exponent, okay, the second power 2 in the denominator becomes the square root. So here we just have it to be times 1 over that. When the negative is here, you can take it to the front because it's just multiplication. We have 2 square root of x cubed. Okay, well here we can observe that the square root is here and the square root is here, but this is raised to some power 3. We can do some cancellation, alright? We can do some cancellation as saying square root of x divided by 2 times, here is just to the power of 3, and that is, we call it square root of x again. Now, this is raised to power 3, so we can write it in 3 multiples, alright? Yeah, so that will just become, let me rewrite this. So we have 2 times square root of x times square root of x times square root of x. Here, we have to the power 3, so it can be written as this. And this will cancel one of it. Okay, so at the top, we just have 1. And at the bottom, we just have 2 times square root of x. Since 1 is gone, we are just left with the remaining 2. You can just square that. And you know that this is the same thing as saying 1 over 2 times the square root of x squared. This and this will cancel out. This right here will cancel out with this square root sign. We're going to be left with x. And that is what we get. Remember the minus in front? This was the negative sign, this was negative, this was negative. So the minus is right here. And this is the answer, that is dy dx. Here, this is pretty simple. You can go ahead and do this, alright? Lane of 2x. Just use this method. 1 over 2x times the derivative of 2x with respect to x and just 2. You cancel out and you just left with 1 over x. Same thing here. So this is just equal to 1 over x. Just go ahead and try this, alright? Okay, thanks for watching. Please subscribe to this channel.